Let's get started with natural language generation. For this, let me hand over the stage to Dr. Ratish Pudupulli. So he's at the he's a postdoc fellow at the University of Edinburgh, and he has been working with us on creating Indic BART and the Indic NLG suite. So Raj is researcher at NICT Japan, so he has also been involved with this work. So Ratish, over to you, so you can kind of continue.
Hello everyone, I am Ratish. I am going to talk today about our work on natural language generation for Indian languages. At a high level, what does natural language generation mean? So it can be defined as, it can be thought of as comprising of multiple tasks, each of which generate text. So it could be, it could take a form of machine translation. For example, we have input as English sentence and we want to translate it into Hindi. Or it could be automatic summarization of a news article into a shorter summary, which describes the important details of the news article. We could have table to text generation, where the task is to describe some statistics. For example, it could be some financial accounts, and we have to generate a financial report out of it. An emerging area of natural language generation is dialogue generation. We see these chatbots which respond to user queries. Then there can be paraphrase generation, where the task is to generate a text which is similar in meaning to an input sentence, for example. And then there are other use cases or other applications which fall in the umbrella of natural language generation. So in the context of Indic languages, what are the things which are missing? As Anup has mentioned earlier, that the modern deep learning era is mostly standing on the pillars of huge pre-trained language models. So one thing to note is that these models have been trained on equally large amount of data as well, right? So when we look deeper into what these pre-trained models are, or basically which languages we have these pre-trained language models for, right? They are predominantly for higher resource languages such as English. So for Indic languages, we didn't have both the pre-training data as well as the large language models. The second part is the NLG training data. So once we have the pre-trained language model, we need some task-specific data, which will tell our model how to do, for example, summarization. So for which we would need some examples of pairs of news articles and their summaries, right? Again, such data exists, but mainly for English. So there is a paucity of data for Indian languages. And the third scenario is that ideally we want our natural language generation models, or we want these models to be able to generate text in multiple Indian languages. So our approach here takes three forms or three parts. The first part, we leverage the Indic Corp monolingual corpora in multiple Indian languages, and we use that to train Indic BART, which is our pre-trained language model for generation. We also make use of language similarity. Here we make use of script unification. The main idea here is that, let's take an example. So I would say that a Hindi speaker can understand, for example, easily understand Gujarati text. But if a Hindi speaker is asked to read Gujarati text, that person might find it difficult, mainly because it is text, it is written in another script, right? So the idea is that here what we do is that we leverage the similarity of the two languages by making use of script unification. We convert the different scripts into a common Devanagari script. Finally, we make use of techniques to auto-create training data for natural language generation. Again, the main intuition or the main impetus here is that when we're talking of, say, summarization again, it is difficult for humans to create data which contains news articles and, for example, the summaries, right? So what we do is we make use of mostly automatic techniques to crawl data, existing data, and then create these training data. So let us go into a bit more details of how Indic BART is trained, for example. So as I was saying, we train Indic BART based on Indic Corp. Indic Corp has around 450 million sentences, and we train IndicBART using a denoising objective, which I'll explain in the next slide. One thing to note is IndicBART is fairly compact in terms of the number of parameters. It's around 244 million parameters, which is much smaller than equivalent large multilingual pre-trained models released by Google and FAIR. For example, the MT5 and the MBART models. So our models, though being smaller, as I'll show in the next slides, the results are almost on par or maybe even better. And other advantage is that we cover more number of Indian languages compared to the MT5 and the MBART models. Okay, so let me go into a bit more detail about the script unification aspect. So we here try to cover maximum number of Indian languages, right? And we know that Indian languages have their own writing script, have their own distinct scripts, so which will need large vocabulary, right? So and again, as I was saying, because these languages are related, ideally we should make use of some this relatedness concept. So what we do is we convert to Devanagari, which results in increased vocabulary sharing, which further results in compact vocabularies because they are all in Devanagari script, and which has a direct impact on the fewer number which directly results in fewer number of parameters for IndicBART. So this is an example of script mapping that we do. So on the left hand side, we have a text in Tamil which is mapped to Hindi, which is mapped to Devanagari script, Naan Oru Payyan. And again, we have another example in Malayalam which is mapped to Devanagari script, Nyan Oru Payyan. So we can see that there is a vocabulary sharing occurring in the word Oru. So this is one example where script mapping will help or in reducing the vocabulary. Now let us look at how IndicBART is trained. So at a high level, IndicBART makes use of a denoising objective. So let us look into how that happens. So let us take an example. Mujhe Bhashantar Pasand hai, right? This is a well-formed text in Hindi. What we do is that we corrupt this sentence. We add noise to the sentence by masking some tokens at random. For example, we mask Bhashantar on the input. And now the task is given this corrupted sentence. We have to generate this correct sentence or the original sentence, right? Likewise here, I love translation becomes I and then mask, and then we have to generate I love translation. So now with this 450 million pair data set of corrupted and the correct version of the sentences, we will train IndicBART, right? So we have, this is the pipeline. We start with IndicCore, we unify the scripts into Devanagari, and then we do the denoising training, and then we end up with IndicBART model, right? So now when you look at it, right, we can have a high level idea or intuition that the model already has a good understanding of how text in Indian languages looks like, right? Because it is trained to generate these correct, well-formed sentences, right? So our intuition is that, or our hypothesis is that this will reduce the need for task-specific data or data which is needed for fine-tuning. So now again, the hypothesis is that after IndicBART has been pre-trained, we only need maybe say a couple of thousand examples of summarization data of news articles paired with their summaries, and the model should be able to do a good job because it has already learned the language. Now it needs only fewer sentences to learn the task. Another point I want to mention is that along with IndicBART, we release a IndicAlBART model, which is a further compact version of IndicBART, wherein we share the parameters across layers. Okay, so now let me give some more details of how we create the NLG training data. So the first task that we create data is for biography generation. Here, we pair Wikipedia info box with the first sentence of the corresponding Wikipedia page. So this is an example of Murmu becoming the president. And then this is an example of headline generation. So what we do is that we extract from IndicCore all the news articles, and we map those news articles with their corresponding headlines. Okay, so that's the task of headline generation. Next, we look at the task of sentence summarization. Again, from IndicCorp. So here, an intuition is that the first sentence of a news article is typically an extension or an expansion of the headline or the title of the news article. So we define this task of sentence summarization as given the first sentence of the news article, generate the headline of the news article. So the headline, as I was saying, is a really generally smaller and more succinct version of the first sentence of the news article. So again, for this task as well, we obtain the data from IndicCorp. Next, we define the task of paraphrase generation. For this, we make use of the Samanantar parallel corpora, which we have. And so Samanantar corpora contains parallel text. So here on the left-hand side, we see this example in Hindi, map with two sentences in English. Okay, so Delhi Vishwavidyalaya भारत में उच्च शिक्षा के लिए एक प्रतिष्ठित संस्थान है. So now our intuition is that if you have an identical sentence in Hindi mapped to two English sentences, that two English sentences should be paraphrases of each other. Okay, so that's the intuition that we use to build our paraphrasing data set. So we do this for multiple Indian languages. Next, we define the task of question generation. The task of question generation, in this task, we have an input of context of a paragraph and a couple of answer words or answer tokens. So given the context of a paragraph and the answer words, we have to generate a question which will generate or which in a question answering model will produce the same answer words given that paragraph. Okay, so a data set for this task already exists for English. We use IndicTrans, which has been trained on Samanantar data set to translate that to multiple Indian languages. Okay, so now let us look at the results. So here on this slide, we primarily look at machine translation results. And for evaluation, we make use of the metric BLEU. On the left-hand side, we have trained models on PMI, PIB. This is generally or relatively standard corpora, which is a small size corpora, using which we want to demonstrate how pre-training is beneficial. And so the setup here is that we use IndicBART and then fine tune on the PMI, PIB corpora, and then we evaluate on the WAT workshop on Asian translation shared task test set. Okay. On the left-hand side here, we primarily compare with MBART 50, which is a large pre-trained language model produced by Facebook, which has support for 50 languages, and it is bigger in size compared to, or more than double in size compared to IndicBART in terms of number of parameters. Okay, and we also compare with a model which has been trained from scratch on the PMI, PIB corpora. So through which we can demonstrate the usefulness of pre-training. So for our first conclusion is that IndicBART compares almost, when we compare the results of IndicBART versus say MBART, we achieve slightly better results than MBART, which shows the importance of language-specific pre-trained models. So as I was saying, though our IndicBART is smaller, but it still is achieving better results, both in both in Indic language to English direction and English to Indic language direction. Next, we compare our IndicBART with a model trained from scratch, and we see that our results are much better than model trained from scratch, which shows the importance of pre-training. Okay. So that's about like fine-tuning on the whole data set. Now let us look at a couple of other scenarios. In the first scenario, we look at a use case where we have languages such as Nepali and Sinhala. Okay, the task is Nepali to English translation and Sinhala to English translation. So we have to note that these two languages IndicBART has not been trained on. So IndicBART has been trained on 11 Indic languages, which does not include Nepali and Sinhala. So now we want to evaluate if IndicBART can be utilized for evaluating on languages which IndicBART has not been trained on. Okay, so we have, in this case, we have fine-tuning data set for Nepali to English and Sinhala to English. And we fine-tune IndicBART on these two language pairs, on these two data sets. For Sinhala, we map Sinhala text to Devanagari. Nepali is already in Devanagari script, so that's fine. And so this is our results. And we see that, and we compare with a model which has been trained from scratch on these two language pairs. So compared to a model which has been trained from scratch, the Scratch model, our INDIC-BART model achieves much better results in for both the language pairs. Okay, so which proves that there is some positive transfer happening from the languages which INDIC-BART has already seen during pre-training to these couple of language pairs. Okay, and that shows the efficacy of pre-training as well. Next, we look at a scenario where INDIC-BART is evaluated on languages, for example, Kannada and Punjabi, which INDIC-BART has seen during pre-training, but there is no fine-tuning data. Okay, so let's assume that there is no fine-tuning data for Kannada to English in both directions and Punjabi to English in both directions. Okay, so this is more a zero-shot setup, which Anup also mentioned in his presentation. So we do the model doesn't see any fine-tuning data in these two language pairs for Kannada to English and Punjabi to English, and we also compare with our INDIC-BART model, which sees those language pairs as well. Okay, so now if we look at results for translating into English, we find that a zero-shot model, right? The red bar is the zero-shot model. Performs slightly lower, only slightly lower compared to a model which has seen these languages also during fine-tuning. So which is a really encouraging sign, right? For the translation direction of English to Kannada and English to Punjabi, our models are lower, relatively lower compared to a model which sees these languages during fine-tuning. But again, it's encouraging to see that it at least achieves some results, right? So it's a zero-shot scenario, right? It has not seen this data during fine-tuning, but it still achieves some results. And now let us look at the evaluation on other NLG tasks. And here we evaluate using Rouge and iBlue. Rouge is for the summarization task and iBlue for paraphrasing task. We evaluate on multiple tasks: biography generation, headline generation, sentence summarization, paraphrase generation, and question generation. And in this, we primarily compare with MT5 model, which is a model, large pre-trained model released by Google. And the model sizes are similar, but MT5 has seen much larger amount of data than INDIC-BART. And we also compare with a model which has been trained from scratch on each of these data sets. Okay. So on an average, we see that our INDIC-BART model performs slightly better than MT5, which again demonstrates the importance of language family specific or limit a few number of related language specific pre-training, and much better than models which have been trained from scratch. So to summarize, we contribute the first large-scale datasets, benchmarks, and models for INDIC NLG, and we present INDIC-BART and INDIC NLG benchmark. INDIC-BART, as we have seen, is a compact language model for 11 Indian languages, and INDIC NLG benchmark, we create generation datasets for 11 languages and 5 tasks. And we show that our models, though being smaller, are competitive and maybe also outperforms the large language models. Sorry, I missed one slide here. Yeah, so our plan ahead is to support more number of INDIC languages and train on more diverse data. So INDIC Corp is primarily a news domain. We want to expand to other domains as well. And we also want to produce more data sets for open-ended generation tasks such as story generation. And in future, we want to create our own INDIC GPT model, which so I guess most of you have seen these GPT models, which given a small prompt about unicorn will generate a whole story about unicorn and so on. So something similar we want to generate for, we want to train something similar for Indian language as well. And then we also want to do more research in more efficient pre-training and fine-tuning. So again, Anup had given an example of like a few short fine-tuning and so on, or only fine-tuning few of the parameters or percentage of the parameters of the whole model. Yeah, so thank you.